Hello, bro. Can you hear me now?
Yeah, I can hear you.
Oh, fantastic, fantastic. So let us
Yes, I
message
can hear you
guide.
now.
All right. So let me just you know. All right. So just give me 2 minutes, please. All right. So let's kick this off. All right. So can I have your screen, please? Hello, Mr. Shomoye. Hello, Mr. Shomoye. Network issues and stuff, man. Hello, Mr. Shomoye. What's the issue? Bye. Hello, are you back? Hello?
Yeah, I'm with
Hello?
you.
Oh, fantastic. So
Yeah,
can I have your screen? We are long overdue for this session.
okay.
Yeah.
Have you gotten it?
Fantastic, fantastic,
All right then.
fantastic. So let's have you one time for all.
Hey, very good afternoon, everybody.
I'm Abiodun. Basically, not like I'm not an expert, but I'm an enthusiast. And we are all in the business of big data. So it's quite a pleasure to be the one facilitating this event today. Not necessarily the teacher. Everybody has one or two things to add. I think I must appreciate Adela for finding me worthy of this honor. I think we can kickstart any moment from now. Dela, is everybody
Yeah,
ready?
yeah. We're all ready. Yeah, we're all here.
Okay, without wasting much of our time, we'll be looking at introduction to big data, what it is, why it matters. We're looking at big data analytics, putting big data to work, and also we'll be looking at creating a big data enabled organization, bringing big data analytics home. So while I think not every one of us is quite unfamiliar with the buzzword big data and the more like should I call it the surface now, the analytic part as well. Almost every one of us have had. Are we together,
Yeah, we are.
Adela?
Yeah, we are.
Okay. Almost every one of us have had one or two things or have read one or two things about big data. As we all know, technology has advanced. We have medical devices generating data. We have our mobile phones generating data sets. We have sensors around us generating data sets. We have our social media generating data sets. More importantly, the new, should I call the new health challenge, which is more of the mental issues, mental health of human beings. We see so many people demonstrating so so much data on the internet space that could have been used to make some decision about their lifestyle in general. So everywhere we move, everywhere we go, we find one or two um, facilities and technologies supporting big data, and that is why it has become imperative of us to take it as important as it is posing itself. The views about big data is quite different from the views about the then data structure. And in the early days, we have data set of 100 rows and found them quite very important. I even say that some years back, data is more like accessible to the first class people in social hierarchy. We care less about what the people beneath the first class, what their information and how important it is to us. But the recent paradigm shift has necessitated the reason why we must have a change of mind. Everyone have access to what a first class person have access to. You might be using an iPhone and someone in the village is using Huawei. Both of us are using a smartphone. So both of us are generating data sets. And this large increment of people who are generating data sets and who are producing data sets, these increments in devices generating data sets, producing data sets, these increments in technology supporting the storage and processing of this data set and all have actually made this domain, as Yola would say, the good of our time. So we've been talking about big data, data set, big data, data set, big data, data set. What do we really mean by the concept of big data and data set? And I said the difference between big data and the conventional data is the big part of it. And there are some reasons why we have the big part of it there. I can succinctly summarize this big into three V's. Let's take it as three V's or four V's. But most importantly, the three V's are quite much necessary to be satisfied to ahead of the four V's. They are essentially four V's, but the first V in the cycle can be pardoned to not be that important. But there are three other ones that are quite important. So we focus on the three V's first before we move on. We look at the four V's. The three V's comprises of velocity, variety, and volume. So let me move to the next slide and see. Yeah, this is where we are. So by velocity, we are talking about the rate of generating this data set. Data set is not just where we have to keep one per 10 minutes. It's not the one we have to keep one per month or keep one per quarter of the year or keep one per year. In some instances, then we have situation where stock data sets are only captured on some predefined number of days. You can say next 10 days and all. That is because the technology to make sure that these data sets are well kept was quite expensive. But with the increment in what you call access to technology and the cheap rate at which technology comes, the rate at which these data sets are being created has increased exponentially. And if we have such facility at our end, there is no need for us to be lazy about it. We are still lazy keeping data set of a month, and next 1 month you keep data set, next 1 month keep data set, or I mean keeping and generating. At that point, we are not in line with we are not satisfying the first V of big data, which is velocity. We are talking about data set with high rate of generation and storing. We are talking about data set of, let's imagine the facility on social media network, for instance. We have millions of users at the point in time tweet their opinion. Millions of users on Instagram share their picture. Millions of users on Facebook post or like something. Those are data sets that we can't even calculate accurately what number or total number of data that is being generated per second. If you have data set that is quite close to what your imagination cannot capture the rate at which you are generating it, then you are turning towards big data. So the first V that must be satisfied before we say a data set is big is that we must have a very fast rate of generating this data set. Let's go back home. In pharmaceutical industry, for instance, transactional data sets of orders, transactional data set of customer feedback, a transactional data set of other basic transactions, and most importantly as well, transactional data set of web lab activities. For the past years, proven to be of large magnitude in some big pharmaceutical industries. Are we together? For the past years. Adiola,
Sir?
are we together?
Yeah, we are. Yeah.
Okay. For the past years, big pharmaceutical industry can't manually handle the rate of patronage. And there's something called, I think, moving forward, this program will have to take into consideration those concepts. Market basket analysis. The concept of market basket analysis is for you to let's just call it reposition and rearrange your store to know which goods go along each other per consumption. I mean, well, per transaction. So if you have big data set for where we can make this very strong and more like very critical decision, we can make this kind of decision on 10 transactions. We can't say because 10 people have gotten this together, then majority will get it together. But if we have thousands of rows or different users, different instances doing this thing together, then we can have much better confidence to say, yes, this is why this thing is like this. So the essence for the emphasis on big is to give up some level of confidence. And I said, big data is everywhere. Pharmaceutical industry, I just cited 3 examples: transaction, customer feedback, and also some other transactions that you guys are much familiar about. I mean, which rather. So the next B we'll be looking at is variety. Variety is quite very important, and this most technologies people want to bastardize. You might see people walking up to you and say, "Yes, I have big data. I have lengthy list of data. I can say I'm one of the producers of big data." And the next question we ask them is, "Let me see the dimension of your data, then see names of customers who have patronized them without other qualifying attributes. We can just see just first names amounting to thousands of rows, and they are already saying they are in the in the domain of big data. No, don't let us misunderstand the concept of the 3 V's. So the first thing that we must understand when we're looking at variety is that for us to have a data set that can qualify to be big, it must come with different dimensions. We must have different viewpoints to it. There must be relationship between several or among several dimensions with which it comes. Let's take, for instance, transactional record for pharmaceutical transaction. We can have name of the purchaser, prescription given, dates, so many other things that could come alongside it. There are instances where during the harmattan period within this part of the world, Nigeria to be precise, most asthmatic patients tend to have their crisis during this period. We can't say that because I've had about 10 people saying it. But we have a data set that captures when the purchase was made, what was bought, at what period of time, who bought it. So many questions can be answered. At that point, we can draw some relationship and see what is the relationship between this period and the drugs people are buying. From there, we can know that yes, within the period of 10, within a harmattan period, most Nigerians come to patronize inhaler. Then we know we need to stock our store with much more inhaler. So those are the critical decisions that we can make with data that satisfy the variety. Just imagine we only have record of people that bought the goods without specifying what they bought, the prescription they brought, when they bought it. Then it will be quite ignorant of us to say, yes, let's just go and stock up more inhaler. So that's the concept that the variety brings into play. It comes with new dimension, gives us reason to establish relationship and some other things like that. So the next thing is the volume, the big man itself. The big man is volume. When we're talking about volume, we're talking about the length, the magnitude in terms of count, in terms of number of records that we have. We have tens of hundreds of records. I doubt whether we can qualify that as big data. I doubt whether we can make learn anything tangible from that and expand it to the world at large. So before we can say yes, we have big data, having satisfied the variety, satisfied what do you call um velocity, we must also satisfy the concept of volume. By volume, we are saying we need much numbers of rows of different instances. We have close to 900,000 different instances. Probability of having 900,000 unique, possibly unique scenarios is quite very low. We have 900,000 instances that we're having 900,000 unique scenarios. It's quite very impossible. So with the fact that we have much volumes gives us much relationships. Rather almost similar to variety. The difference between this and variety is that we have different dimensions in variety to draw knowledge from. Volume now gives us the confidence to drop that volume. This thing has been carried out and has been drawn from a larger percentage, not just tens of people. We are looking at hundreds of people. So the concept of volume, variety, and velocity are not mutually exclusive events. They must occur together. The only V that I found quite mutual exclusive among them that I don't find very much important is the concept of veracity. Veracity. By veracity, I mean we can't really picture the nature with which the data is going to come from. There are several potential or several behavior of the data. That Abiodun has come with a different stance doesn't mean the next person coming will come
Hello,
with a
sir.
different. Yes, sir.
Is your slide changing or is just on the first slide?
Oh, sorry. Has it changed now?
Yeah, it does. Thank you.
I'm sorry, I forgot. So we're speaking about velocity, variety, and volume. So let's look at veracity, uncertainty of data. One, we are not certain whether data is going to come. We're not certain whether data is going to come in the picture, in the domain or the perspective with which we want it to come. We might be interested in getting customer feedback, and we are so interested. Oh, don't worry, I will satisfy them for so long, and every one of them should come with a very good opinion about us. We are so sure, and we got data that satisfied that uniformity in opinion. Then I might be telling us that our knowledge, the domain from such data seems urinary. We are just looking at a single perspective, and there is no need for us to explore resources if what we are doing can only be seen from perspective of just one possible outcome. So our data set, if well structured and there is no atom of this and that, veracity will always be satisfied if the other three V's have been satisfied. So veracity is talking about uncertainty of data. Before we can say data set is big, there must be some atom of uncertainty with the nature in which the data set is going to come out with. So at this point now, we've probably seen what really qualifies data as being big. So anybody with one or two question, addition, subtraction at this point before we move further? Anila?
Any question? I don't think there is any question at the moment.
Okay, so we can move to the next slide.
Yeah.
So the promise of big data, aside from the word that is big, everybody is talking about it, everybody wants to know about it, everybody is doing it, but not everybody. But what really is motivating people to move into this? I always say this, that every human activity, if carefully studied and organized, would define whoever the person is. If you look at me very well and draw a very big picture about me when I was 10, and about me when I was 20, about me when I was 30, possibly very little of my notes will have changed if I come close to 40. So that is just the basic summary of what big data actually promises us. It's within big data sets are several possible scenarios. Within big data set are several knowledge. So having this thing gives us a basic to make some intelligent decision. So summarily, the major promise of big data is the knowledge that we are getting out of it. And once we got the knowledge out of it, then we move to action. So big data is giving us a from what do you call probability. We are moving from probability to possibility. That is just the basic promise of big data. So, but there are some other things that comes alongside it. The traditional issues that we had, the issues we have with traditional techniques, and also what the big data is doing differently. Let's previously, veracity, I said, does not account for biases. The traditional method where we have very few, very minute number of rules or number of instances, we care less about bias. We don't know what subjective perspective the data set will come with. So we care less about the noise. We only want to capture the good ones. We care once it is not satisfying what we are doing, then we can deviate back to um, deleting it entirely. And we care less about abnormality. I remember doing a service here, we were asked to do a count of some villages, and when we got to a place where we investigated, we interviewed the man. They said he was close to 140 years old. Every one of us thought this man actually said 140 because probably he wasn't educated. At that point, we just queued. We just this man can't be more than 70. Everybody with this. So those are things that previous instances didn't make us to be cognizant of. So previous data set that statisticians claim to be the originator of does not put into consideration the concept of bias, noise, and abnormality. But with big data, most of the data sets are not being stored by human beings, they are generated. Human have very few or minute control of what is going on, what is actually going on. So these abnormalities, these bias, this noise are all stored. And all these three things account to the uncertainty of our data set. So basically, the traditional method that we had didn't afford us the opportunity of seeing things from different perspectives. But the way introduction or the advent or the birth of big data has given us a new insight. Now we can see things from several perspectives before make decision, making our knowledge not just be skill. I mean, what they call localized. Let me just use that word. So we can't just say that man, we know what is going to happen. Nobody is sure of what is going to happen. Nobody will have predicted that some instances will have affected some stock and some little things like news or some little things like politicians defecting from one party to the other could affect the stock price. Nobody will have thought of such. But once we now look at the data set that have several of these factors put together, then we can now picture which one is becoming more important and more of the key actor. And again, the traditional method also does not put into consideration real-time analysis. Real-time analysis is we want to be able to make meaning of data as it is coming. This is mostly used in once stock predictor senses a change in data set. We want the stock predictor to be able to respond immediately within a click of time. We don't want it to be some so-called specialist sitting down and saying no, don't let us consider it. So this time around, the new facility and technology that support data, big data, comes with real-time architecture that can understand change immediately and reflect the importance of that change. Then what we had was people, experts, sitting down and looking at what could have been the difference, what could have made that difference outside what you know. But at that point, the damage will have been done. But at this instance, what we have currently is that there are technologies that can learn immediately and afford, and ensure that the potential damage is obstructed. So that's another very good perspective that big data is bringing into the into the game. We have then also compatibility. Compatibility is quite very uh, important to look at, and it was a very big problem back then. Then you know that whenever a statistician wants to analyze data set, the first thing the person goes to ask you is, oh, what type of feeds do you have? What type of data type do you have there? What type of this and that and that. Those are issues that they had. So they basically oftentimes have the problem of relating with several forms of data type. in the real sense of it, probably that skipped my mind. We have several types of data set. We have data set generated from numbers. We have data set generated from text, our alphabetical, our words, our daily conversation. We have data sets generated from pictures. We have data set generated from audio recordings. We have data set generated from video recordings. What we are doing today, all of our conversation, we are generating data. So look at, imagine this type of data being handed over to some good statistician, get statistic guys to process. They get dumbfounded because they were brought up, not their fault. That was the technology that are available. The technology available that put them into study, that structure their domain, does not have the what do you call, the wherewithalness to take into consideration data set of different types. Most of the algorithms that they have, most of the methods that they have rely heavily on previous numerical data types. That's why we see them talking about descriptive analytics majorly. I doubt that you can carry out descriptive analytics on text. Those are the new things that the domain of big data and technology that companies has brought into the game. We can deal with any form of data set, regardless of the type, regardless of where it's coming from, regardless of the source, and regardless of the extension it has behind it. So the ability to deal with much complex data sets has brought some sense of relief and has given human effort and human knowledge some new morale. Now we can care less about what the data is coming from and where it's coming from. All we care about is let us process it as against what we had before. So the other one is the volume. Yes, and I said majorly when we talk about volume, we are looking at the size. Hardly will you slot in 1 million rows in an Excel, for instance, and you won't be seeing something dragging for so long before you get the output. And in a big data sense of it, and the promises that the technologies are coming with, 1 million is just a child's play. Slot 1 million to Google platform, slot 1 million to some other cloud platform, you just be laughing and within thinking of an eye, 3 minutes, 5 minutes, everything is done and dusted. So we are looking at it from the ability to gain knowledge. The basic promise is the ability to gain knowledge from what looks so complex then that the big data has made so simple. So it has given us a perspective, a notion that everything is solvable. And with the way things are going, we don't know where we are moving. The promise looks brighter than what we are even foreseeing. We've heard about robotics, serverless driverless cars, and so many other things like that. Those are promises that big data is bringing into the picture. As I always said to the earlier that there are instances, they were scientists, they were mathematicians, they were computer scientists, they were computer theorists who sat down, who has been sitting down for the past so many years trying to use some other methods to bring in robots into perspective. Well, hardly would they have known that the development of data, big data, could have made their work so simple. So the basic thing is that big data is making what used to be complex quite much simpler than we would have thought. So at the future, we are looking towards a personalized system. We are looking towards the pharmacist being able to look at the data and say, yes, this is the drug that just this same person will be using this drug. We are looking to a point where every one of us will have our own personalized paracetamol. We have our own personalized anti-malaria drugs and so many other things like that. So in the domain of pharmacy, we are looking at possibility in nearest future of having personalized drugs that you can look into your patient that brought bring prescription and be able to say, no, your drug is quite different from others. Possibly before then, Nigeria will have found reasons to have data set of what's a big data set of who we are, what we are, and our genetic makeup. With that insight, the ability to have personalized medicine, personalized healthcare facility becomes quite very simple. So for pharmacists, the future and the promise of big data is enabling of personalized health system. Any question before we move forward?
Yeah, any question? No, not none for now.
Okay. So types of big data. We've spoken directly, probably indirectly on this thing. We poked our nose before we actually get there. But look at type of big data. Let's just go over it. As I said, I've made mention of media in form of images, video, audio, flash, live streams that we are doing, podcast, what do you call, so many other ones like that. Though these things we've carefully studied, if carefully structured, and if carefully processed, can lead to a new form of knowledge. If we carefully analyze our live streams now, we can carefully picture, use different each of our voices for different what knowledge. You can be able to capture, was it really Abiodun that spoke, or was he another person that formed his voice? So many other things that media could do to us, image analysis, and very much sure that most of us will have seen the new reports about the Abuja Army child clash. We saw real-time analysis of images and the what do you call, and the environment. We saw real-time analysis of videos. With that, the truth was, we were able to be presented with the truth as against what the Nigerian army told us. We saw a more different perspective to it. We saw the real thing happening. Data doesn't lie. Human ways can lie, but data, it's not in the nature of data to lie if carefully processed. So that the promises that media forms of data what do you call make has made available to us. The other one that we're looking at that I think I found very, very interesting these days is social media data. Almost every day, so many instances of suicide that we found so far on the Twitter, for instance. I've seen some of the users who are victim of these things giving us some hints, but hardly majority didn't take the difference or the changes in their behavior into as that serious that it could lead to the form of it could lead them to committing suicide. So on the social media daily basis, human beings share what is happening to them. These are things that can be carefully studied and put into psychological perspective to make some decision, some informed decision, not just a decision this time around. So on social media, basically, so many people are releasing several information. So many people on LinkedIn are posting their job posts, their skills, and there's so many job recruiters out there that can just do pattern matching, use some pattern matching algorithm, and know that this is the person that best fits our job. Facebook as well. Most of them are. I am very happy to even make examples of Facebook, Twitter, and LinkedIn. These guys are basically using people's data to do target advertisement. They learn from what we are doing and recommend advertise goods for you. They read what you've posted and see what could this person like. These are people that are not seen or they haven't seen us for one, but they already define who we are by what we post. They already define who we are by what we've given them. So data goes beyond, let me just lie. Data gives you some uh-oh.
Hello? Hello? Wow. Hello, Mr. Shomoye. Hello, Mr. Shomoye. Oh, wow, we lost him. So please give. Give me a few minutes to connect back to him. All right. Before he comes back, I took a few notes and I have a few talking points. So he talked about generating big data. He talked about 3 V's of big data. So that's the velocity at which data comes in, the velocity at which we generate data. For example, in the pharmaceutical industry, in Nigeria, for example, we generate, what we generate in the pharmaceutical industry is basically big data, patient transactional data, like he mentioned, transactional data, all of the patient interaction, drug interaction data, all of the pharmacogenomic data, all of that data is big data. So in Lagos, for example, say we treat in a day, say we treat 500,000 patients, all the community pharmacies. I don't know how accurate that is. If we treat 500,000 patients in a day, then in a month we would have had more than 5 billion data sets to work with. And we see that this helps us when it talked about personalized medicine. With all of these data sets, we could arrange people into groups based on their genetic makeup, based on their age. Oh, all right. Based on their age, Mr. Shomoye just apologized. There was an issue with his network. Based on their age, based on their occupation, based on their temperance, the way they talk, something as minute as anger issues, right? We can use all of this data to do big personalized medicines, and that comes to when we talk about personalized medicine, talk about 3D printing. So you come into the pharmacy, we print your own paracetamol, we print your own antibiotics, not the general antibiotics. And this you can see in personalized marketing, where Facebook uses your pictures. So if you go to Facebook right now, you don't need to tell Facebook that you're a pharmacist or to tell Facebook that you're some healthcare professional. Just by your pictures, the things you write, Facebook already puts you into several classes, such that when someone wants to market, right, and the person says, okay, I want to market to a pharmacist, you get to see Facebook ads, right? It talked about moving from probability to possibility, right? So I talked about epidemiology, AI and epidemiology, where we have people predicting who's going to come down with what sickness or not. So that's going from probability. So you're first in the probability of risk factors, right? The normal risk factors were taught in pharmacy school. So this person has this habit, this person smokes, this person drinks, this person takes this kind of drug. So he's at risk of this kind of disease. We are moving from probability to possibility to pinpoint accuracy that you are going to come down with this disease at so time, so you can prevent it and save healthcare costs. He talked about bias, noise, and abnormality. In the YPINAI course, in the machine learning course, you'll be treating these 3 things: bias, noise, because there's a lot of noise in the data sets you're going to be working with. So you'll be multivariate and monovariate statistical analysis to check out the balance of your data sets. So it talks about different types of data sets. We have numbers, we have words, that's text analytics, we have pictures, we have audio, and we have video. 4 weeks ago, was it 3 weeks now, where we had our first live session, if you remember, I spoke to you guys about this guy, Ubenwa. So Ubenwa is an AI startup, and what they do is that they take the voice of newborn babies, right? So when the baby is born, they pass his voice through his AI system to detect if the child has what's the name of this disease now? I forgot the name of this disease. But that's an example of how you can use audio data, to gain insights to treat diseases and personalized medicines. You can use pictures. Dr. Daibo is coming in on the 27th of January. Dr. Daibo is a medical doctor, is a full stack AI engineer. So he has a startup where he uses his AI system to diagnose, it's called Retina AI, right? To diagnose diseases in the eye. I mean, these are crazy stuff that we can do with data. And most time, unstructured data, so to say, the text, the pictures, the videos, the audios are the real big data. The ones that you see in your rows and columns are what I want to call small data. But the ones that you cannot really put into a column that you have to vectorize before you can gain insights from it are the real big data, right? It said data doesn't lie, and really, if truly processed, data never lies. So it talked about people who commit suicide on Twitter, and they leave cryptic messages, and most times we are not able to pick them up because we are humans. But machines can pick these things up. You can write an algorithm that tells us who is going to commit suicide in the next few weeks. I tell you what, last year at AI Saturday, I watched a YouTube video by Siraj Raval. Right, Siraj Raval is a sensation in the world of AI today, where he used, I picked up a project where he used support vector machines. The support vector machine is like linear regression. It's an AI algorithm, right, to detect who is going to commit suicide or not. Now, there's a parameter we often come up with in the community pharmacies, the pulse pressure. Now, pulse pressure is, so most times when you do BP test, right, you see the systolic, diastolic, and the pulse pressure. Then you look at systolic and the diastolic, and then, okay, mommy, any BP, or mommy, you don't have BP. Mommy, what drug are you using? Mommy, these are the lifestyle modifications you should take note of, and all of that stuff. We don't use the pulse pressure, and most times when pulse pressure is above 100, right, it means it could mean that the person is going through some emotional disturbance. It could mean that the person is having depression. It could mean that the person is going to commit suicide very soon. That's the example of data sets that we do not do anything with, that we do not. So I ran a project. I had about 20 patients, right? And I had about 62% accuracy. All right. And then this brings me to is variety, right? I had just two parameters. I had just the age. The older you become, the more you tend to have the issues with depression and societal issues and all of this stuff. I had just two data sets, just the age and the pulse pressure. Imagine that if a variety of data sets like the blood pressure, occupation, marriage, and all of that stuff, and I have, say, 3 billion data sets, I will be able to have at least 95% pinpoint accuracy that someone is going to have suicide, and we could help humanity by detecting who's going to commit suicide, and being able to make appropriate actions to save the person's life. Yeah, so those are all the talking points I wanted to talk about. And then it talked about market basket analysis. Market basket analysis is one of the things we are going to be doing in the machine learning class. Market basket analysis. Okay, market basket analysis just says that what's the relationship between two products, right? It's called association rule. Now it's one product associated with one product. It's used in marketing to upsell. So there is a particular product that is really not doing well, right? And so you find the relationship with one product, and then you tag two of them together and then upsell. Or you can put the two of them together on the shelf so that someone that buys egg would usually want to buy milk, right? That's what market basket analysis does for you. So I did a market basket association rule or association mining program for a community pharmacy sometimes in August. I discovered that the products that were closely related in that pharmacy were paracetamol and vitamin C. What they are going to use, what they are going to do with that information, I do not know. But those were the closely associated drugs in that pharmacy. So you could go on and do stuff like that for retail, for fast-moving consumer goods, for online retailing, for just any kind of operation where data is generated. He talked about customer feedback. Most times we get customer feedback. Customer feedback is big data that we throw away and that we can generate lots of money and business value for. But unfortunately, we do nothing with customer feedback. So we are doing all of this. We are holding programs like this to open our eyes to things that have eluded us in the past, right? I talked about how Africa has missed up on the first, second, third industrial revolution, so to say, and we do not want Africa to miss out on them. The fourth one, right? So we are still waiting for Mr. Shomoye to come back. Okay, so we're waiting for Mr. Shomoye. And if you don't mind, I was taking us through the machine learning program. If you don't mind, I would like to continue. And if you're online, I at the beginning of the previous session, I took us through installation. So while we are waiting for Mr. Shomoye, I would like to take us through the installation package once again. Okay, so. Okay. So installing Python, right? So this is the link to the Python download section, python.org/download/Windows. To download the latest version of Python 3.7.2. But if you have 3.4, 3.6, you are good to go. But if you have 2.7, you might need to upgrade, right? No one uses 2.7 again, at least in the data science world, right? And then after moving on to Python, if you're using a Windows, you use that. If you're using a Mac, this is the URL for Python installation for a Mac OS. And then after you've downloaded Python, you go on to install Anaconda. So this is the URL for Anaconda download. That's at www.anaconda.com/download. And when you get in here, you choose which one you're using, whether it's Windows or it's Mac, you're using a Linux environment, right? So it has over 1,400 data science packages that you can use for your data science work. And after downloading Anaconda, you can go on to download Visual Studio Code. If you are in the world of software development, you understand why I'm in love with Visual Studio Code. But basically, you're going to be using Visual Studio Code to upload your projects. You're going to be submitting your projects to GitHub, right? So you're going to be using Visual Studio Code to upload your projects to GitHub. And then last but not the least is GitHub, right? So go to github.com, create a profile, and then boom, submit to Slack, right? So these are my repositories. You see my repositories. These are all of the work I've done in data science and artificial and web development, right? So all of my work is here. It's a repository it's a code repository, such that you don't have to, when you are working in the software world or in the programming world, you don't have to save your work on the flash drive or on your computer because it could crash or your flash drive could get missing. So you upload your stuff to Git, and then GitHub is called is used for what we know as continuous integration. So you could be here and you could be doing some data science job or some AI project with someone in Canada or as far as the Antarctica, right? So GitHub is a continuous integration platform for software developers and data scientists. So, and you're good to go. I made a few presentations in the last session. I for people who are in the machine learning program, I said the first thing you need to do is upload your picture, right? Upload a profile picture. So edit your profile and upload the picture. After doing that, you need to introduce yourself on the general section, because on the general channel of the Slack group, because we need to know who you are and where you are. And then we need you to read our code of conduct. This is very important. We are going to be very strict with our code of conduct, right? Because we have different kinds of people in the program. We have people from different countries. We have people from Ghana, from Uganda, from Zimbabwe, guys from Kenya, South Africa, Cameroon, and so on. And so we want to have a very inclusive program. And then after that, you take the primer course and submit your answers to the assignment channel. If you're on the Slack group, I believe you should be, you should be familiar with the Slack environment by now. And unfortunately or fortunately, today is the deadline for submission of the primer course, right? And then that is the link for taking the primer course, elitedatascience.com/primer. And then this and this and that. So Mr. Shomoye should be joining us any moment from now. Any moment from now. Hello, Mr. Shomoye. Wow. Wow. Oh, this is a tough one, man. Okay. We're very sorry for the glitch. We'll be back in a few minutes. For then, I don't know if there's anyone with a question. You can ask your question on the YouTube channel, or if you want to ask your questions via Hangouts or in person, I'm going to be posting the link in a few minutes. So please stay with us. Before Mr. Shomoye comes on as well, for those of you still, based on where you are, there are different AI communities that you can take advantage of. So if you are in Lagos, for example, there's AI Saturday Lagos that happens every Saturday. And if you're in Ibadan, there's AI Saturday Ibadan. If you're in Abuja, there's AI Saturday Abuja. Abeokuta, there's here Saturday Abeokuta, there's here Saturday Port Harcourt. If you are in Kampala, there's here Saturday Kampala. If you are in Rwanda, there's here Saturday Kigali. If you're in South Africa, excuse me, if you're in South Africa, there's here Saturday Joburg. There's an here Saturday. Okay, there's an AI Saturday, community in every city. Someone is asking a question about identifying a dummy and indicator variable. So an indicator variable is basically that variable that has a very high correlation to your target variable. For example, if you are trying to predict, for example, who is going to commit suicide or not, the indicator variable is that. Okay, I can't find you. The indicator variable is that variable that is highly correlated, like the pulse pressure that I explained. So in every statistical analysis, in every data science work, there are going to be variables that you cannot do without, and there are going to be variables that are just noise, variable that you really don't need. And if you put those variables into your work, you're going to have a very bad model. You're going to find that your model is performing very badly, right? And then there are dummy variables on the other hand. Dummy variables when you get into the machine learning program, you see an example of dummy variables. For example, when you are running a regression analysis, for example, you need your variables to be in numbers. So you find some categorical variables, for example, in the video, in the picture I showed you, the roofing. If you remember the roofing, there were woods, there were different kinds of roofs in words. Now you need to convert those words into numbers for your machine to be able to process them conveniently. In every data science field, whether you are processing pictures or you are processing videos or you're processing audio texts, or you are processing words, like you're processing texts. There's something in data science we call vectorization. So vectorization is giving that word a number format. For example, if we have two types of walls or two types of roof, or two types of just anything, I'll say clothes or clothing items in a data set. For example, we have clothes and then we have shirts and trousers. You don't want to take shirts and trousers into your machine learning model. So creating a dummy variable means you are giving shirts 1 and you are giving the trousers 2. You understand? Or if there are 10 different type of clothing materials in that data set, so you give them 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. That way, it's easier for your computer, to know which is which, and then to find correlations within your data. So that's what a dummy variable means most times in data science. I can't find you. Oh, does anyone have any other question? Any other question? Please just throw them to me. All right. Let me to while away some time. Let me take you guys through the market basket analysis I did a few months ago. Right. So while away a few minutes. So I'm sharing my slide right away. All right. Let me know if you can see my slide. Right. So this is a science work environment, and let me take you to where I did some work on transactional data in a community pharmacy. All right. Thank you. This is it. Thank God. I'm sorry, guys. My internet went off. What do we do? Good. Tired. Let me try to connect Mr. Shomoye. It's taking some time that I don't understand. I don't know why. I don't know why. Oh God. Okay. Let me go on with my presentation. So I made mention, right? The grouping, right? So yeah, I've forgotten what this is called. I'm trying to remember what it's called, but this is a way of vectorization. So all of these texts that we add, right? All of these texts that we add, I need to convert all of them into numbers before passing them through my machine learning algorithm. So that's what I did here. Right? And then I converted. Then I used the sum to Boolean function to convert everything above 1 back to 1. Right? So it's either 0 or 1. It's either it was sold or it wasn't sold. So I did that, and then I ran my machine learning algorithm. I used an a priori algorithm, and I used the ML extend framework to import my machine learning algorithm. So I imported a priori rules and I imported association rule. Right. So the a priori rule, the first thing it did for me here is to show me the most valuable item in this store. So from here, I can detect that paracetamol M&B sachet is the most sold drug in this store, followed by vitamin C by 1,000, followed by Luxagil tablets, which is metronidazole, followed by Nomoretic tablets, which is a blood pressure, drug, followed by enzopracetamol. So you can see that people buy lots of analgesics in this store, followed by Ceflonac, and then vitamin C, Vasopressin, Loratadine, and all of that stuff. After that, what I did next is that I passed an association rule on the a priori algorithm to show me the relationship between two products. So the antecedent and the consequence. Here, the antecedent is Envite C syrup, while the consequence is paracetamol. You can see under this as well that paracetamol and Envite C are very, 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 related. You can download all of these documents to study which drugs are most related, which drug you can use to sell another drug. You can look towards drug interactions there. You want to know if any of the drugs you sell constantly are interacting with each other. You can make lots of inferences from there, and then you can export, to CSV, and then do your analysis. So that's all on the market basket analysis. I'm thinking we would have to postpone this session, do a recording and send it to you, because the network situation here is very, very, very disheartening. Very disheartening. I'm very sorry. I'm very sorry for this, but we wouldn't want to take your valuable time doing nothing. All right. So I'm going to wait for about 5 minutes. And if we don't get Mr. Shomoye, then we'll have to postpone this session to maybe midweek. maybe sometimes within the week, probably Tuesday or Wednesday. We have to postpone this. This is not making any sense at all. Alpha boss. Okay, no wala, no wala. Look, I'm going to postpone this. 5 minutes, all right. So Mr. Shomoye asked us to give him 5 minutes, and after that, we're going to be off. We're going to be off. Okay, before we go, I would show you something else. Where is my screen? Right, something else. Screen. All right. So this is a customer segmentation project that I did and that you are going to do sometimes in April, right? Well, so the data set has been anonymized, so I'm free to show you, right? So I imported data set. This is how my data set looks like. Invoice number, stock code, that's the code of every item in the inventory, right? The description of the stock, the quantity bought, the invoice date, that's the time this purchase was made, the unit price in dollars, this is in Canadian dollars, customer ID, and then the country. This is taking place in the UK, so that's in pounds, right? So df.ed gave me the first 10, All right, Mr. Shomoye is back. Hold on, please.
Which one is this one you're doing?
I was just taking them through some of the projects I was doing, just to while away some time.
Okay, I'm very sorry that anything is doing anyhow.
All right, so let me have your slide. Okay, fantastic.
So we're talking about the data from social media. I said there has been so much issues and challenges. There are still very much challenges to be resolved. Coming from medical concepts, we might most likely be also involved in the task of psychological analyzing opinions and looking at the medical implications of whatever output we were able to draw out of the data set available to us. So as I was saying, almost every human being currently today depict or exhibit who they are on the social media network. So that's a potential source of data for us where we can get a description or more like a representation of whoever the handler of the account is. And I was saying earlier on that Facebook, LinkedIn, Twitter, Instagram, all these big guys have been using whatever we've posted, whatever information we've submitted to make informed decision about us. So social media also has stand and currently will continue to stand a very to stand as a very good source of data as regards the development of this field. The next one we'll be considering so certainly is the sensor data. Medical devices, smart electric meters. Quite surprising that recently I got to know about I got to know about the smart electric meters around Lagos. It's quite surprising that they are trying to develop algorithms that will be able to study user patterns and be able to predict and prevent what do you call breach of their facility. So those are other forms of data set that basically I think aside from the medical devices, we have less or no other things to do with traffic recording devices and the likes that are there. But also just to paint a picture rather that data can also come from sensor. Next one is machine log. Yes, machine log, your POS, your event loggers, what do you call? Most e-commerce website these days, most transactional software these days are built with the capacity to save data that we don't even know they are saving. They save this data at the back end. They save our transaction at the back end. Most of us will have seen click what do you call this a robot. That thing sounds so disturbing to some people. This image checker on most of the websites that we visit on daily basis, the sensor doesn't just check whether we click it, it also checks how long and how many times did we maneuver or did we take our mouse over the image that was given to us. These are information that ordinarily wouldn't believe that they are being logged. These softwares log this information, and this information can be used to dictate whether it is a real human being that is doing it or it's actually a robot. So there are some other data that most systems that we use, most softwares that we use, most websites that we visit on a daily basis captured. And this data, imagine being captured across 7 continents, across over 5 billion people, who out of them could be 100 million using at a second. Just imagine the number of data that is being generated. This is another source of data. The machine log data, most times, in most instances, comes in alphanumerical. It has numbers, it has tests, and it has so many other things. And same thing is applicable in the medical field. You might imagine a customer coming to buy. Yes, you have a POS or you have a stationed robot where the system can communicate to. That makes your work quite easier. You can take these activities to check who is coming. There are some instances where they are checking medical readmission. They want to take, okay, you've logged into the system. How sure are you that you are not going to come again? Based on the previous data that has been saved, those who logged in and came back, what are the factors that make that possible? What are the features they have and all? So machine log as well also contains data sets that could be of important use. And again, we've made mention of business apps somewhere there, mobile app usage, business app, project management application, customer relationship management application, HR. We don't really have much to do with that, but I'm very much sure that we might also be integral in the use of customer relationship applications. These applications that tends to store your customer, the perspective of your customer about you, most times feedbacks and all. These are things that could help you reshape the way you build or rather attend to your patients, your customers. Basically, most pharmaceutical industries, aside from those that the like production end, those at the retail and wholesale end, needs to make sure that they have a very full grasp of their customers. No one wants to have a customer churn. No one wants to lead customer to the other. Are you there, Adiola? Hello.
Hello? I'm here. Can you hear me? Hello? 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 Hello, Mr. Shomoye. Hello, Mr. Shomoye. Oh my God. That's the end, guys. I apologize. We would need to postpone this to some other time. Thank you, guys, for staying with us. Thank you so much. As you can see, there's no power, right? Network is bad. Network is rescheduled to some other time. I apologize although these are situations beyond our powers. There's nothing we can do about this. No power, no network, but we'll do what we need to do. I apologize. We'll postpone till Tuesday or Wednesday. I'll let you know when, and I'll make sure that it's as fast as possible. So thank you so much.